I am calculating the area of y is equal to f of x from the limit a to b. Thus, area of a function here can be represented as integral from a to b f of x dx. Whenever area of any curves falls below the x-axis, you should remember that you should always take the modulus of the given integration. The circle is equally divided into 4 quadrants which has equal area in all the 4 parts. So here also, if you find the area of this AOB and multiply it by 4, it will give you the entire area of the circle. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So in this chapter, we are going to study about the application of integrals. We have studied some of the standard integrals, that is to find the indefinite integrals of a given function. So one more application of studying integration is to find the unknown areas under the curves. So here we have area under simple curves. So let's study how we are going to find the area of simple curves. Now area under the simple curve. So here I have taken an example of a curve y is equal to f of x which is continuous in the closed interval a comma b. Hence I have taken the limits x is equal to a to x is equal to b. So here I am calculating the area of y is equal to f of x from the limit a to b. Thus, area of a function here can be represented as integral from a to b f of x dx. The same curve can also be calculated with respect to y-axis. So, let's take the limits from y is equal to c to y is equal to d. Here, the function is represented in the form of x is equal to g of y. Thus, area here is represented by limit c to d g of y dy. So, here whatever you integrate, here the values will be with respect to y, and there when you take area from a to b f of x dx. So here the variable you are going to use is x. So x with respect to dx, whereas here y with respect to dy. Next. Now the curve under consideration which lies below the x-axis, that means here your f of x is lying along the negative side of the x-axis. So therefore when you take the limits from x is equal to a to x is equal to b, here the area of the function should be written in the form of modulus of f of x because area is always positive. Suppose you take the curve sin x, we know that the sine curve is from 0 to 2 pi here. Now if you calculate the area here, it is from 0 to pi. If you calculate the area of sin x from 0 to pi, it is equal to 2 square units. Similarly, if you calculate from pi to 2 pi, that is also 2 square units. That means one arc of sin x, the area is always 2 square units. But when you take the limits from 0 to 2 pi and you apply integration of sin x, then this will be like cos 2 pi minus cos 0 form. That means area of the upper curve cancels with the lower curve clearly. So the value will be 0. That means your area is 0 here. That means there is no curve. So which cannot happen here. So in that case, we will divide the first half of the curve as first function and second half of the curve as the second function under the modulus of the given function. Then we will get the area in terms of 4 square units which you will be studying later. So whenever area of any curves falls below the x-axis, you should remember that you should always take the modulus of the given integration. Next, again, I told you that if the curve is continuous and it moves on along the positive and negative side of x-axis, then it is divided into intervals by the properties of integral. Suppose you have an integral from a to b, then we can divide the integration from a to c plus c to a. Using this property, we can just divide the curves with respect to the interval, calculate the integral value, and finally, we will add all the definite integral value to find the total area of the given function. Now, since you can see the curve here, so if this is the region A1, which is lying below the x-axis, then the total area is modulus of A1 plus A2. Why A2? Because it is along the positive side of the x-axis, that is above the x-axis. So here the area is positive, but here you will get area as negative, which you make it as positive using the modulus function. Now let's take few curves and find the area of these curves. Find the area of the region bounded by the curve y square is equal to 4x, y-axis and the line y is equal to 3. So here we are going to find with respect to y-axis and along the line y is equal to 3. So the diagram for this question you can see clearly. So y square is equal to 4x is a right-handed parabola. So this represents y square is equal to 4x. And along the y-axis, we have the line y is equal to 3, which is intersecting at certain point. Okay, so we need to find the intersection of these area. So what is the required area of this? So here, area is equal to integration of y dx. So we can clearly see here, y square is equal to 4x and y is equal to 3. Suppose if you take y is equal to 3 in this equation, we have 3 square is equal to 4x and x value will be 9 by 4. So this point of intersection is 9 by 4, comma 3. So thus x can be taken from 0 to 9 by 4 here. So here this value is 0, comma 3. So if we take in the form of y dx, then the limits goes from 0 to 9 by 4. If we take in the form of x dy, then the limits you can clearly observe with respect to y-axis. Now, what is y here? We have y square is equal to 4x. So, y square is equal to 4x means what is y? So, here y can be converted into y is equal to root 4x, which will become 2 root x. So, thus the region y can be written as 2 root x dx to the integral from 0 to 9 by 4. Let's keep 2 outside the integral, and if you apply integration of root x, then it is x to the power 3 by 2 divided by 3 by 2, and the limits are from 0 to 9 by 4. So, it is 2 into 3 by 2 can be taken out before applying the definite integrals. So, then 2 by 3. So, x to the power 3 by 2 means 9 by 4 to the power 3 by 2 minus 0. So, here 9 you can take it as square root of 9 is 3, square root of 4 is 2. So, then it is 3 by 2 whole cube. So, here you have 2 2s are 4 divided by 3 into. So, 3 cube is 27, 4 cube is 8. So, 4 1s are 4 2s are 3 1s are 3 9s are. So, therefore, the value is 9 by 2 square units. So, this is how we are going to calculate the area of the given curve with respect to the integration. Next, find the area bounded by the curve y is equal to sin x between x is equal to 0 and x is equal to 2 pi. So, here I have represented the sine curve from x is equal to 0 to x is equal to 2 pi. So, you can clearly see this is your 1 and this is your minus 1. So, the maximum range that sine can reach is 1 and minimum range is minus 1. So, at sine pi by 2 it is 1 and 3 pi by 2 it is minus 1 and sine any pi is 0. So, thus the curve of sine function goes like this. You can clearly see the half of the sine curve is above the x-axis and half of the sine curve is below the x-axis. So, therefore, here integral from 0 to 2 pi sin x dx will split this in the form of 0 to pi sin x dx plus I'll take the modulus. Why? Because it lies below the x-axis, and here we'll take pi to 2 pi sin x dx. So, this is how we will write the integral value. Now, what is integration of sin x? Integral value of sin x is minus cos x. So, minus cos x with respect to the limit 0 to pi plus again here minus cos x with respect to the limits pi to pi under the modulus. So, if I keep minus outside and apply the limits here, then it is cos pi minus cos 0. And here, again if I keep minus outside, then it is cos 2 pi minus cos pi. So we need to apply the modulus sign here. So cos pi is minus 1, cos 0 is minus 1, minus 1, minus 1, outside is minus, which becomes 2, and plus. Next we have cos 2 pi 1, cos pi is minus 1, minus of minus 1 is plus 1. So minus of 2, and under the modulus it becomes plus 2 again. So 2 plus 2 is 4 square units. So thus the area of the sine curve between 0 to 2 pi is 4 square units. Next question. Find the area of the region bounded by the line y is equal to 3x plus 2. The x-axis and the ordinate x is equal to minus 1 and x is equal to 1. So we have a straight line which is passing through the point minus 2 by 3 comma 0. How will get this? Just by converting this equation. So if you put here y is equal to 0, then we'll get x is equal to minus 2 by 3. So that is the intersection of this line along with the x-axis. Now you can clearly see few portion of the area from x is equal to minus 1 to x is equal to 1, it is below the x-axis. So here also we need to split the area into a1 plus a2, whereas a1 is modulus of the given function and a2 we can easily find. So let's split this. Area is equal to integration from here x value is x is equal to minus 1 to x is equal to minus 2 by 3. So minus 1 to minus 2 by 3 f of x dx. So here f of x is 3x plus 2. So into dx under the modulus because the area lie below the x-axis plus again minus 2 by 3 to 1. So integration minus 2 by 3 to 1 f of x dx, which is 3x plus 2 dx. Now when we solve this, here we'll get 3x square by 2 plus 2 with the limits minus 1 to minus 2 by 3 under the modulus. Again here we have 3x square by 2 plus 2 with the limits minus 2 by 3 to 1. Now here if you apply the limit as minus 2 by 3 and minus 1, and if you solve this, the modulus of this function will give you the value 1 by 6. Similarly, if you take x as 1 times minus the lower limit, here you will get the value as 25 by 6. So we have 26 by 6, which is 13 by 3 square units. So solving the upper limit minus lower limit value will give you these. Then the final answer will be 13 by 3 square units. Next question. Find the area enclosed by the curve x square by a square plus y square by b square is equal to 1 by the method of integration, and hence find the area enclosed by the curve x square by 16 plus y square by 9 is equal to 1. So clearly we can see this equation represents the ellipse. Now we need to find out the area of this entire ellipse. But what I will do, we know that ellipse is symmetric. That means the upper half of the area is same as the lower half of the area. And also in each quadrant, it is exactly divided into 4 parts with the equal areas. So just you calculate the area in the first quadrant and multiply the value by 4, you will get the entire area. So let's calculate only the area AOB and multiply by 4, which will give you the entire area of the ellipse. Now before that, we need the area in the form of y. Okay, so that is from 0 to a. So we are calculating only from 0 to a, from the first quadrant, 0 to a y dx. So we are calculating only the area in the first quadrant. If we need the entire area of the ellipse, then we need to multiply by 4. But before that, let's find y. So using this equation, we can write y in the form of b by a root of a square minus x square. So on reducing this equation, we'll get y as b by a root of a square minus x square. So thus here we'll get 4 times 0 to a b by a root of a square minus x square into dx. Now b by a is constant. Let's keep outside the integral. Then we need to integrate root of a square minus x square dx. Root of a square minus x square is one of the standard integral whose value is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. And the limits is from 0 to a. Now let's apply the upper limit minus lower limit. So we have 4b by a. So let's apply the upper limit, that is x is equal to a. So what happens here? Then it is a by 2 root of a square minus a square plus a square by 2 sine inverse a by a. So this is your upper limit minus lower limit. That means wherever you have x, you should take it as 0. So if you put 0, this entire thing is 0. And if you put x is equal to 0 here, sine inverse of 0 is 0. So therefore, it is minus 0 only. Now let's solve this. This terms to 0 because a square minus a square is 0. Now we have here 4b by a square by 2 sine inverse of 1. A cancel. Now for what values of sine we'll get it as 1? For pi by 2. So therefore sine inverse of 1 can be written as pi by 2. Now here a cancels. 2 2s are 4, 4 cancels. So the value is pi a b square units. So this is the area of the required ellipse. Now they have also asked an additional question. What is the area of this curve? X square by 16 plus y square by 9 is equal to 1. So when we take x square by 16 plus y square by 9 is equal to 1, this implies a square is equal to 16, which implies a is equal to 4, and b square is equal to 9, which implies b is equal to 3. And we know that the area of an ellipse can be written in the form of pi ab. So for this equation, area is equal to pi into 4 into 3, which is equal to 12 pi square units. So this is the required area. Next question. Determine the area enclosed by the circle x square plus y square is equal to a square. So the limits is not given. Again, I am taking a circle whose center is origin here. Now, when I take the limits a, so the distance from 0 to a is same as 0 to a to here, and wherever you take, it is constant because the radius of a circle is constant. So therefore, the limit is from 0 to a. Now again, the circle is equally divided into 4 quadrants which has equal area in all the 4 parts. So here also, if you find the area of this AOB and multiply it by 4, it will give you the entire area of the circle. So therefore, area is equal to 4 times 0 to a y into dx. But what is y here? We know the equation of the circle is x square plus y square is equal to a square. So if we want y, then it is root of a square minus x square. So we cannot write here plus or minus here because area is always positive. So let's take only the positive value of the square root here. So therefore here again it is 0 to a root of a square minus x square dx. Basically, we know that the area of a circle is always pi r square. So here, the distance of the radius is a. So the answer should be pi a square. So let's check with the help of this integration now. Now, again, this is a standard integral, which is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. So limits is from 0 to a. Now again, if you apply the upper limit here, so we get 4a by 2 root of a square minus a square plus a square by 2 sine inverse a by a. So this is your upper limit value, whereas lower limit is entirely 0. Now this term will become 0 because a square minus a square is 0. So we have 4a square by 2 and left with sine inverse a by a, which is sine inverse 1. So we have 4a square by 2 into pi by 2. 2 2s are 4, 4 get cancels. So pi a square units. So this is the area of the required circle. Now, the same circle can be asked with x-axis and giving the limit as x is equal to 1, x is equal to 2. So that is, if the line is given and if they ask you to calculate only the area in the first quadrant, then no need to write 4. So only the area enclosed by the circle x square plus y square is equal to a square with 0 to a can be written in the form of 4 times the given integral. If they ask you to calculate the area only in one quadrant, then no need to write 4. Whereas when you are calculating the entire area of any circle or entire area of any ellipse, then you need to write 4 times the given integral. So thus in this session we have learned how integration helps us to find the area of an unknown curves between the given limits. So in the next session, we'll meet you with the next chapter. Until then, keep watching, keep learning, keep exploring. Thank you.